Good morning. My name is Dore Rosenblum. I'm a last-minute fill-in for the presentation. Apologize, Bernard had an issue come up, wasn't able to make it. So I'm going to go through the API security, cybersecurity solutions. So I'll try to keep this as interactive as possible. If you have any questions, please raise your hand. Otherwise, we can talk at the end. So let's talk a little bit about what's happening in the industry today. A lot of the API attacks are not being detected at all. If you look at some of the more recent breaches that have been announced, Facebook last year announced the fact that a large number of their customers potentially had their information compromised, and this was through an API attack where there's a video upload application where the token was compromised and allowed a hacker to gain access to other users' information. So basically, from one account, they're able to get to other account information and basically taking personal information for a number of different users. Another example is the US Postal Service. Here, this one was a little more serious. If you could argue Facebook maybe doesn't have the most sensitive data in the world, but it is a privacy flaw. Whereas US Postal Service had an API which allows you to look up your account and have information about packages, that kind of thing. And what happened here is there was authorization wasn't properly built into the app, and hackers able to basically bypass that and query information about any other account, not just theirs, and not only access the information, potentially change it. So that one was a little more serious. And then there was Landmark White. This one was very serious, whereas 100,000 applicants in Australia had their personal information, this is for home mortgages, and this API was inadvertently exposed, where hackers were potentially able to access information there. In this case, the banks, for their customers, basically cut them off. After this happened, CEO resigns, so it was a total mess. So API attacks are happening. It's really a serious challenge that organizations need to look at today and rectify. So as we look at how these attacks happen, there's different variations in the attacks. We talked about stolen tokens, data extraction, takeover types of attacks. So there are many different examples here. And in all cases, what had happened is there were existing defenses in place. So many of these organizations had a CDN in place that was actually in place to prevent DDoS types of attacks. And many of these are more volumetric in nature, where there's, say, 200 meg of traffic taking down a 100 meg pipe. But it's important defense. Next would be web application firewalls. And with a WAF, again, it's looking at known attacks, things like SQL injection, and making sure those aren't compromising your APIs. You also have other defenses like botnet detection in place, where here it's looking for attacks trying to gain access to the API or maybe disrupt it a bit. And finally, you have the API gateways, which were put in place to provide security, and they certainly provide strong consistency and management of APIs. But with all these defenses in place, these attacks were able to get through and potentially perform things like data theft and other types of abuses on the API. And so what we need today is to take a look to how we take the detection of attacks going from, in many cases, months and years down to where you're able to quickly detect and understand these attacks. If you look at the impact, it really varies by industry. And if you look at the number of new industries starting to look to APIs to help enable the business-to-business communication, this is only going to get worse as things move forward. So healthcare, a lot of APIs are being opened up to provide access to insurance, other kinds of information. Finance industry, of course, you have open banking and other types of APIs there. So this problem is only going to get worse, and really depending on the industry, it affects each differently, but all will be impacted. So as we look at one of the challenges today, it's really the lack of visibility that's causing many of these challenges. As we talk to many different customers, we ask, how comfortable you are that you have visibility into the activity on the APIs, and that you would be able to see if, say, good and bad traffic was flowing across and differentiate between the two. And in many cases, the security in place validates the right people are getting to the APIs, but after that, there's not much visibility into the activity that goes on as the client accesses those APIs. And so that's really the hole right now that a lot of organizations mentioned is a challenge for them. And then beyond that, there are some attacks that are detected, but beyond that, organizations need to go beyond what's there today and be able to detect some of these more advanced attacks, which in many cases have legitimate users finding ways around the controls that should be in place, but for whatever reason, maybe there's a flaw in the design or something, were exploited and allow the hacker to get access to the API data and compromise it. So as we look at artificial intelligence and how it plays today, I mean, API security today traditionally consists of the following. Certainly you have security of the traffic as it flows. You have different rate limiting controls, making sure a single client isn't able to come in and overrun the API. And on top of that, in many cases you have certainly access control and authorization, and often things like WAFs even built in here to make sure that the known attacks are not getting through and compromising the data. So what needs to happen is security needs to go beyond this and offer more comprehensive insight into the activity on APIs, and this is where AI can start to fill that gap. So looking to fill some of these missing pieces, including things like authentication attacks, where say a token is compromised, or a man-in-the-middle attack steals a token and the client's then able to access information, or other types of attacks would include attacks where a client tries to disrupt the API or take over the API. So basically what would happen here is the client comes in and maybe tries to compromise the service of the API just to disrupt it, or comes in and worse, accesses the application and the data behind it and does things to disrupt that. So things like deleting data, extracting data, other kinds of things. So really, the key here is getting the full API activity reporting at scale and having that as a basis and a foundation of what you're able to gain to help understand your environment and the API activity within it. So let's go through one of the more common attack vectors which is used, and that's the API takeover attack, as we call it. So in this case, a hacker comes in and uses a valid account to access information on the API. So the US Postal Service would be a good example of this. Once they gain access, then they look to manipulate and reverse engineer. In some cases, maybe it's a single page app and they find a way directly to the back-end API. In other cases, maybe they just try different things. They can be very creative in trying to manipulate, say, the browser string, which shows the call, and look for ways that can maybe plug different things in and find other information. Once they're done reverse engineering, then they use this approach to go after other information and take advantage of the vulnerabilities that are there. And so they're able to then potentially steal data, do other kinds of things. And these are the attacks which go on for months because they don't show up as your typical types of attacks. Again, it looks like a legitimate user accessing information, yet they're getting access to stuff you certainly don't want to allow them to access as part of their authorization. So what's required to protect APIs from cyber attacks? There are multiple different elements that go into it, and we'll talk more about these in more detail. But certainly they include things like discovering and understanding the APIs in your environment. In many cases, put everything behind a gateway to make sure there is that control there, but making sure there are mechanisms in place so APIs aren't inadvertently exposed. And this has happened in several different situations where APIs that organizations thought were strictly internal or were maybe deprecated were still exposed publicly and created issues. Having the activity audit trails is also very important, and having insight into what goes on and being able to pull that information as you need it. And also alerting you if something looks very odd, and having threat detection as well as the ability to block. And then last but not least, we can talk about deception, where that way you can be more proactive in terms of hackers trying to access your environment and compromise it. If they're probing, doing other kinds of things, in many cases, deception can be an effective solution for detecting them and heading them off, or even have a chance to come in and compromise your API. So let's talk about addressing some of these inaccuracies. So certainly monitoring and having the ability to discover all activity is important, as well as having visibility, which allows you to sort out the different types of traffic within your environment. One of the things we find happens in many organizations is that there are different groups that deploy the API gateways. And so one organization has one vendors, another has another vendors, and so you have multiple different gateways providing API services. So there's a level of inconsistency already built in, where yet each is individually managed. There's no central view of all the activity and potentially all the attacks. So you have to manage that at each gateway to get that visibility. So having the ability to pull all that information together is immensely helpful in having a consolidated view, as well as being able to enforce across all environments consistently. So if an attack is detected on one, ideally that hacker isn't able to go to another and try to compromise it. In addition, there's a need for other types of reporting and visibility and tools which allow you to dive down and get forensics information, for example, if an attack does occur or if you see abnormal activity from a user. All that information is useful in rolling up into compliance reports in many cases, where if you can report on activity, you're able to better manage what comes into your environment. And also from a compliance perspective, we find that some industries like finance are very strict about the information you should be reporting and understanding about everything coming in and accessing your APIs. So being able to log all the access, making sure it all is audited and all that stuff is becoming more and more important in compliance types of reports. So for all these reasons, API security is going to be more and more important moving forward. So as we talk about how you can detect and block attacks automatically, one of the nice things about artificial intelligence is it can drop in and build its models based on understanding your environment. And so rather than having to set up a bunch of rules and policies as to how you want it to manage and look for this type of attack, it's able to come in and understand that automatically, and once its models are built, look for deviations from that. And it's able to analyze the activity from a quote-unquote user perspective. And in some cases, maybe you actually have user information. In other cases, maybe you have cookies or tokens or API keys or something which are used by users, but you're able to look at the activity based on those entities and determine whether or not the behavior is normal or abnormal based on what occurs from that entity. Talked before about the ability to use deception. I'll cover that in more detail later on. And the other nice thing about using artificial intelligence is it's not like it's set up to look for specific attacks. So it's not like, let's say, an antivirus, where you have a new pattern you add every week or to do that. In fact, many of the antivirus have also moved more to artificial intelligence type approaches where they're looking for difference in behavior versus purely looking at a list of attacks they're trying to prevent. As far as how AI works, basically what it begins by doing is analyzing the API activity and creating a normal model. Now, in many cases, you say, well, what happens if my API gets attacked while I'm training the system? And that's okay, since they're based on statistical models, and there's always going to be anomalies outside of that. In general, what it wants to understand is what the vast majority of usage looks like on that API to build its model, and then measures against it. And there are different ways you can look at it. You can look at activity on the API. You can look at activity from a user perspective, as in, is the user accessing APIs you expect them to access? Are they going after ones that you wouldn't expect them to access? All that kind of stuff can be done by the artificial intelligence algorithms to help look for normal versus abnormal behavior. And again, the key thing here is detecting behavior, detecting attacks based on the behavior, not based on a set of rules or policies you have to set up and adapt over time. So it allows you to come in and have some confidence it's going to have visibility. It'll be able to report on what it finds and provide a lot more insight based on its ability to process all the data versus somebody, say, looking through logs or doing other kinds of things manually. And so the other piece is it's able to adapt to changing environments. And so it's not like it's a static setup. In most cases, they'll continuously learn and adapt as the API changes over time and as client access changes. And so it's able to keep up with changes and maintain a level of consistency in the models it builds, and looking for those deviations which really differ, allow it to be very effective over time. So if we look at some of the attacks and vulnerabilities that are specific to APIs, the most concerning would be the data and application type of attacks. So things like someone accessing APIs in an anomalous sequence. So if somebody, for example, comes in and changes the address, changes the password, for example, an account, jumps in and does a major wire transfer and then closes the account, and maybe that's considered odd. And so if you look at the sequence, that can be very important in how APIs are used. And that becomes even more complex when microservice, other types of environments where you're jumping around many different APIs, which may even exist in multiple different places. Other kinds of threats would be things like data theft or injecting data. So I talked with some organizations, one of the challenges they've had is hackers have tried to upload, say, malicious code, other kinds of things via the APIs. So understanding and looking at that usage there, making sure what's occurring is normal is certainly something that's very important. Also, just in general, looking at different types of obvious attacks, like probing and fuzzing, where you're basically trying to manipulate strings just to see if something will work that really shouldn't. I mean, in a lot of cases, there are tests that are run to do this, but if a hacker is trying different things like that, you can sense that, you could head off that hacker before they're even able to get started with their attack. In terms of attacks on authentication systems, I mentioned before the takeover attacks, where a user comes in, is able to compromise the API, being able to go after information they shouldn't. You're able to potentially take over accounts using things like stolen tokens or cookies and the like, and come in. And AI can detect some of these attacks. You always have to be a little bit careful because, for example, a mobile device would change IP addresses from going from a Wi-Fi environment to, say, a mobile environment. So the last thing you want to do is aggressively block every time that occurs. So you need intelligence behind a lot of this analysis to make sure what you're detecting is not generating a bunch of false positives and disrupting users inadvertently. And there are other types of attacks, such as login and probing types of attacks. And finally, there are the more specific API DDoS types of attacks where, again, this is more about a botnet doing something to disrupt versus taking things out. But the last thing you want is, if you're a retail operation, having your shopping cart or some particular service tied up with a bunch of bots accessing it versus legitimate users. And so this is a concern, and what we're talking about here is not necessarily the volumetric attacks where you've got every single user blasting your environment. It's more about intelligent bots where they're able actually to detect the flow control limits you have, throttle it down just below those, and just take their time. And so when enough of them band together, that can be a significant amount of traffic. And so these are the kind of attacks where you want to have some insight and visibility and make sure you're heading them off. In terms of using deception, this is another tool, and it's fairly common in other environments where you have honeypots and the like for things like telnet servers and other types of attacks. With APIs, you can do something similar, where here, what you're doing is setting up a dummy API or a dummy API path such that when a hacker accesses that, you know no legitimate user would go there, so you can be certain that that user is somebody you can quarantine and or monitor more closely or do something about, because they're obviously not running a legitimate API, since the client is already defined as programmatic interface, so the client's only going to access legitimate paths, legitimate APIs. And so anybody who's outside of that, you know, is a hacker, and you can therefore quarantine and take away. So what you can do here is, if a hacker comes in and accesses something that doesn't exist, like an account, and once that happens, you can block them. And in fact, many API gateways offer capabilities to where somebody accessing an invalid URL or path or something like that can be automatically directed to an API that could function as a decoy or something for you. So you have different ways you can set this up to help head off the hacker attacks. So as we look at protecting the APIs today against threats, the three main things we discussed would be learning the behavior and making sure you have the ability to understand what's normal versus abnormal in your environment, and then take action against that. Getting the visibility and reporting, so the ability to both have information which allows you to report the data necessary for compliance purposes, as well as giving you the information to drill down and understand, say, after an attack or something like that, what exactly happened, what else may have been touched, and get much more visibility into the activity leading up to that attack. And then certainly having the ability to automate the attack detection and blocking is another important element, because as you saw, many of these attacks go on for months, if not years, and so having the ability to head them off is something you want to be able to do automatically and not have to rely on a bunch of security analysts pouring through logs and trying to figure out the anomalous behavior. So some of the tools available today allow you to support this automated type of attack detection and blocking to help protect your environment. So with that, I think I'm about out of time. Any questions? Yes?
I'm interested in how you are training your AI. If you train on your system and there's already people that are hackers in there, how does it detect the difference if it's training on the data that already has hackers?
So the question is, if you're training on your using your AI to train yourself, and you already have hackers who've accessed your system, how do you differentiate between how does the model not get confused by that? And what you're looking at is really more of a statistical model you're building with access. And generally what you want to do is train over a longer time period where the majority of the users, or the vast majority, would be normal, legitimate users. And so there is always going to be anomalous behavior in that. But once you build the model with a valid number of users collecting through, you're able to obfuscate that issue, not obfuscate, but eliminate that issue by making sure you have a solid base you trained upon. If you want to catch up afterwards, we can talk about that more. Other questions? Yes?
Just wondering how surging in traffic can be handled by AI. So it's known surging. Like you do a marketing campaign, how would those AI models differentiate between a welcome surge of traffic versus an unwelcome surge of traffic?
So the question was, how would an AI model detect the difference between a surge of traffic that's normal, let's say Black Friday, versus just attack type traffic? Generally, the models look at things on a per user perspective. So a surge would be, let's say, 1 million users versus 500,000. And so we'd be looking at the activity across those individual users and wouldn't be affected by a surge. So basically, we'd be able to differentiate between the different users and not be confused by that. Other questions? Great. Well, thank you for your time today.